Muy bien, un gusto. Well, my name is Emiliano. I am from Argentina. The main reason that I'm here in Boston is because my wife is doing a postdoc here in Tufts University. So we will be here until 2027, I think. I am a Python developer. I have been coding in Python since, I believe, Python 2.2. I don't or 2.0, I don't remember. Well, I would like to start this talk by giving a huge thanks to the organization for putting these events together, for the sponsor, for supporting these kind of events, and a big thanks to all of you for showing up and for giving me the chance to give this talk. So, this is an introduction to PDB. If you don't mind, I would like to ask who has experience using a debugger, if you can raise your hand. Okay, well, that was a pleasure. I hope that you well, I hope that you will find this talk helpful. So, what's PDB? Well, PDB, it's a tool in Python that lets us find and fix mistakes in our code. And what's the cool part about this? It's built-in. It's a Python module. That means it's already included in Python. You don't need to install anything extra. Why do you want to learn PDB? Well, that's the main reason. If you know how to use PDB as it's built-in, you will know how to debug any Python program, no matter where. It's like if you know how to use Vim or Emacs, I don't want to get inside in that battle, but you can edit source code or files anywhere. That's the main reason. So, what's debugging? Debugging a program, it's like, give me a second, a detective work, but for code, let's say. You try to find what's making your program act weird or wrong, and you try to fix it. But for me, debugging, it's not just finding something that it's acting wrong and fix it. It also involves learning. When you are debugging, in that process, you can learn a lot about your Python program, how it's working. So, speaking of learning, give me a second because I have my cheat sheet here. Let's talk about that. For sure, there are a lot of ways to learn, but here I would like to show you a simple 4-step process where we can see on the first step, I have the slides here. To make a stop and take a look. When you are going to learn something new, it's good to take your time, right? Second, it's fine if you can interact with the environment to change things and see what happens once you change that. And also, it's nice to be able to move on, to move forward and see, okay, now I know how this part is working, now I want to go to the next part of the code in this case. And the step 4, I put that like iterate. Repeat these steps as many times as you need or as you want. So, how this relates to the Python debugger? Well, we are going to see that in PDB, it's an interactive debugger where we are going to interact by writing commands, and we will be able to do these steps, but with our programs, to make a stop, to interact with our code, with the environment, to make changes, and to move on. I have prepared like a cheat sheet for you, because we are going to see exactly this in real time in a demo, in the terminal, but I want you to take a look at this. The first thing, there are 3 blocks, right? To stop the program, we are going to write breakpoint in the program. We are going to call that function, and the program will stop. If you're using Python 3.7 or a minor version, then you need to write import PDB set trace. But if you are using a greater version, just write breakpoint. That will, yes?
Can we get the slides after? for your class?
Absolutely. Yeah, if you want to take pictures, photos, that's fine.
We'll get the slides afterwards. All right.
Yeah, absolutely. If anyone wants to interrupt me and make questions, no problem. So, breakpoint will stop the program. Then we want to take a look. For that, we can use in PDB the list, or the shortcut is L. That will print a couple of lines of code from our program where we stop the program. And then we have P, or print, that we can use that command to print the value of a variable. We will see that in a few minutes. And then to move on in the debugger, in our code, we can use next, which stands for step over. That will execute the next line. We will see that, no worries. We have step, which is very similar to next, but step into is a bit different because it will move the debugger inside the function. We will see an example. And then we have continue, which will continue the execution of the program until the next breakpoint, if there is anyone. If there is no breakpoint, then the program will continue. And quit to just exit. If you are in a hurry, if you don't understand something or you don't remember something, you have just type help because it's very well explained in the debugger itself. You can type net help, yeah, that's very helpful. So jump to terminal. Of course I have, please don't sleep, no, don't now. Give me a couple of minutes. So, I have built, here we have a really simple Python program. My goal was for you to learn PDB. So, it's a program that will build a car. If I execute it, build car, whoa, that's not part. Sorry. So it will just print a Toyota car with an engine and 4 wheels. So let's take a look. Build car. And
can Eugene tell you how fast that car is going?
We can do it as a feature request in the next release. So here we have a couple of functions. If I take a look at the bottom, we see that once the script is executed, it will call the makeCar function, and it will print the message that we already saw. So I will put a breakpoint. Remember, to put a breakpoint, just write or call the breakpoint function. Going here, breakpoint. We call this function, I save the file, and then I will jump to a new tab that I have here, and I will execute the program. Build car, ta-da! Welcome to PDB. Here, this is the PDB, the debugger. It's interactive, what means that you can do anything here. For example, 1 + 1, and it's evaluated. Don't be afraid of the debugger. It's meant to test and do stuff. So where am I now? Okay, I'm in the PDB. I have wrote the breakpoint here, but where am I? Now I want to take a look. Remember, to do that we use the list command or the shorthand L. Boom. Now that print exactly what we see in Vim, right? We see the breakpoint and we see this arrow. An important lesson here, this arrow means this is the next line to be executed. It's not where am I right now or what already has been executed. It's the next line that will be executed. And how do I execute that? That is like moving forward, right? Okay, I am in the breakpoint and now, boom, one step forward. I want to execute the next line. How do I do that? Using the next command or the shorthand N. Boom. L to list again. Oh, yeah, seems that I'm one step forward, right? N, L, N, L. And you can see that the functions are being executed and I am moving forward in the program. What can I do now? Because now I want to see, for example, what's inside in secret part, which is the value. Oh, great. Which is the value that this variable has? Well, for that, remember we have the print command, and I will do I will use it as is. P or print, the long version, secret part. And we see the value, or P part 1. Remember, it's an easy example, right? So with print, we can see what value has any variable. Also, you can copy, for example, I can copy this function call and execute it in the debugger. You can call any function that is reachable in the scope of this function, okay? So we see how to stop the program, how to move to the next line, to execute the next line, how to print any variable, and now I will use C, that it's continue.
What does line 16 do?
Sorry?
Get wheels.
One more time, please.
What does line 16 do?
Line 6 do? 16. We don't have a 16 line, sorry.
Right there.
16, get wheels. Get wheels just return a string.
Line 16 itself defines the function.
16, sorry. Yeah, it's defining here. Thank you. Yeah.
And you're seeing like the wheel.
Oh, it defines get wheels as puts it in a string? Okay.
Well, I will execute it one more time because I want to show what's the difference between next, which stands for step over, and step S, which stands for step in. So let's execute again. Python will car. Sorry, Python will car. List, next, list. We see that here a function is going to execute. The next line wants to execute get secret engine part. But I want to, it would be great if I can jump inside that function. For that, I will use the S command instead of the next. So once I do that, or step is the longest version, boom, then you can see here the arrow is pointing to the line that you mentioned, 16, line 16. And now we can list the code. We can see that we are going to get inside this function, and now we can use next as always. Well, it's like using step. It's useful when you want to get inside a function call and continue debugging there. Disclaimer, sorry, this is my first talk in English, so for sure I will do a lot of mistakes in grammar and in pronunciation, but well, thank you for your patience. So, any doubts related to the difference between next and step? Now it's clear. So, we have seen all of these commands. That's cool, that's great. Now, I want to talk about stack trace and stack frames. Please, yeah.
Yeah, I'm sorry, maybe I missed this, but can you unexecute a line and then go back to the previous one? So for example, if you're assigning a value to a variable, you go back and then unassign and clear out the variable. Does that?
No.
No,
let me know if I am understanding. Oh, no, not that presentation. Yeah. I want to jump to the terminal here. Python 3, builtin. Just to confirm, you are telling me, hey Emiliano, is it possible to go back to part 1 and change that value? No, at least I don't know how. But we are going to see now that I want to explain or introduce the concept of stack trace and stack frames. We will be able to do some kind of that. Give me a second. Well, who doesn't, he, she, it, doesn't, don't. He doesn't, yeah. Who doesn't know what is a stack frame or a stack frame or a stack trace? Please raise your hand. Cool. Well, everyone is like experts here. Well, I already created a slide, so let me talk about this. Well, a frame is a data structure that Python, the interpreter, will create every time that a function is called. And Python itself, you don't have to do anything, will destroy that frame once the function returns. That's the first concept. The second concept is what is a stack trace. A stack trace is another data structure which is an ordered list of stack frames, one on top of the other. The one, yeah, keep on with that. And the most important thing is you always remember to read the stack frames from the bottom to top. That means when you have that on your screen, remember from bottom to top. Don't do on the other way. Now I have prepared another simple example. We have function underscore 1, function underscore 2, and function underscore 3. We see that when the program starts, function 1 is executed. When function 1 is executed, great, you can see my cursor. Python create a frame for function 1. When function 1 returns, Python destroy that frame. So function 1 here called function 2. Function 2. Function 2, a new frame is created for function 2. Function 3 is called. So boom, it jumps to function 3, a new frame is created for function 3. When function 3 returns, the frame is destroyed, only the frame for function 3. Then function 2 returns, the frame is destroyed, removed, and here the same. Function 1 return, the frame for function 1 gets deleted. So now it's something related with your question. This what I know how to do is how to navigate the stack frames. You can navigate up and down. And to know where you are located, we have the W command, which stands for where. Where am I? Don't confuse that with list. List the code. Here you will see where are you located, but in that list of function calls. So jump to the terminal. Again, give me a second. Now we are going to use another example. Call stack. Bin call stack. Well, it's the same example that you saw in the slide. I'm going to put the breakpoint. Oh, it's already here. Okay. So let's execute this. Python call stack, Python 3. Call stack, boom. List the code. Just a quick tip, you can use list and tell, hey, show me from line 1 to 20. Boom, and I can see more code exactly here. It's a quick tip. So, we are on function 3. If I write the W command or where, here we can see the call stack. The last, and remember, always read from bottom to top. So here we can see function 3 was executed by function 2 on line 12. Function 2 was executed by function 1 on line 18. Is this true or this is lying? Okay, let's check. 18, boom, we see on line 18, yeah, function 1 is calling function 2. And well, then function 1 is executed by the module on line 23. If we jump to line 23, we can see that here. So why this is useful, Emiliano? Well, when you have a problem, you are trying to figure out why this behavior is not the expected one. It's really useful to take a look back which functions were executed before and in which order, because it can give you a hint where you need to look at. And in the debugger, you can navigate the stack frames. How? Well, you have up to one level up, and you have down to go one level down. Let's see that here. Up. If I list, I was moved to function 2. And can I print the value of B? Yeah, you can. Boom. And if I move one level up, and I list the code, I am on function 1. And I can print the value of A, the variable A, yeah, P, A. And okay, that's fine, but now I want to go again to function 2 because I want to test something. Down, because we want to go one level down. List, we are in function 2. Make sense? For me, it was a challenge to explain this because sometimes it can be a bit confusing. Well, I'm really glad if you understand that, if you understood this. Mission accomplished. So,
Emiliano,
yeah.
what would happen if you tried to go to, in function 3, what would happen if you executed a down command there? Or up after the first one?
Excellent. I like that question. I forgot to show that. Well, so if we are in function 3, and we type where, we see that there is nothing more down. So if you write down, Python will tell you, hey, this is the newest frame. There is nothing newest than this frame. And if we go up, it's like an elevator, right? We take an elevator up, okay, we are in this frame, up, we are in this frame, up, we are in this frame, up. What's going to happen? All this frame. There is nothing more, okay? So that's what happened. Thank you. Yeah.
Can you modify state up and down the stack as you go?
Can you?
Modify state. Can you change the variables as you go up and down the stack?
I don't know, but let's test it.
Function 2, or like,
Yeah,
you change it.
let's test it. So, next, and next. Whoa, sorry. Up. And let's say yeah, but to do that, I'm pretty sure. Give me a second. I need to test that. So, if we go, for example, here, we are going to say function 3 will accept an argument, b, which was defined before. Function 3, let's accept something here, and let's make that, I don't know, to print that. Wait. And let's test that. Call stack L going up one level. At least now B. Okay, let's print B.
Yes.
But B now is going to be Boston rules. Oh, why I can't do that? Because B is a command in. So we are going to do foo. Well, let's try that after the.
Exclamation point at the beginning of that expression. If you put an exclamation point at the beginning of that,
Yeah.
that will just end it.
Thank you. Like this.
Okay.
Equals here function 2. Well, thank you. What happens here? B is a command in the debugger, so it didn't allow me to set a value. But if you use the exclamation mark, you can do that. Thank you. So now let's test what we want. Function list from 10 to 14. Okay. Step inside. One more time. P. Print B. No, it didn't assign.
No, you changed it back.
I changed it by Python rules, no? Yeah, now S to step inside the function. Now we are here.